Welcome to our deep dive into the world of electrical motors. These incredible devices, often hidden away inside machines, are truly the unsung heroes of modern engineering. Today we'll explore how these marvels of electromagnetism have revolutionized our world. Get ready to be energized because we're about to unravel the mysteries behind motors, from their basic principles to their vital role in our everyday lives. We'll journey through the history of motors, explore the different types that power our world, and discover the ingenious parts that make them go. So buckle up, get ready to spark your curiosity, and let's get this show on the road. So how do these seemingly magical devices actually work? Well, it all boils down to a fascinating interplay between magnetism and electricity. You see, every magnet creates an invisible area around it called a magnetic field. Think of it like an invisible force field, attracting or repelling certain metals. Now, when you introduce electricity, things get really interesting. When electricity flows through a wire, it generates its own magnetic field. This is the fundamental principle behind electromagnetism. A motor cleverly uses this principle to create motion. Imagine a loop of wire placed within a magnetic field. When electricity flows through this loop, it creates its own magnetic field that interacts with the surrounding field. This interaction creates forces that push and pull on the wire loop, causing it to rotate. It's like a game of magnetic attraction and repulsion, making the loop spin like a dancer on a stage. To keep the motor spinning continuously, we need a way to switch the direction of the electric current flowing through the wire loop. This switching is done by a device called a commutator, which is like a rotary switch. As the loop spins, the commutator changes the direction of the current, ensuring that the magnetic forces continue to push and pull in a way that keeps the motor rotating smoothly. The speed of this rotation is determined by the strength of the magnetic field and the amount of electric current flowing through the wire. More current, more speed. It's like giving the motor an extra jolt of energy. And there you have it, the basic principle of how motors transform electrical energy into mechanical energy, all thanks to the amazing interaction between magnetism and electricity. The story of the electric motor is a testament to human ingenuity, a tale of innovation that spans centuries. Our journey begins in the early 1800s, a time when scientists were just beginning to unlock the mysteries of electricity and magnetism. One of these pioneers was a brilliant British scientist named Michael Faraday. In 1821, Faraday conducted a groundbreaking experiment that demonstrated the principle of electromagnetic rotation, the very foundation of electric motors. Faraday's discovery paved the way for the invention of the first rudimentary electric motors. These early motors were simple devices, but they held immense potential for the future. Fast forward a few decades and we meet another giant in the world of motors, Nikola Tesla. Tesla's inventions and innovations in the late 19th century revolutionized the field of alternating current AC electricity, which proved to be ideal for powering electric motors. Tesla's AC motors were more efficient, powerful, and reliable than their predecessors, paving the way for their widespread adoption in various industries. The 20th century witnessed an explosion in motor technology. Engineers and inventors around the world made remarkable advancements, developing new types of motors for countless applications. From small, precise motors used in household appliances to massive industrial motors powering factories and transportation systems, motors became the driving force behind the modern world. Today, electric motors are everywhere, quietly and efficiently powering our lives in countless ways. They've become so integral to our world that we often take them for granted. But let's not forget the pioneers who dared to imagine a world driven by electric motors. Their legacy lives on in every spinning fan, every whirring hard drive, and every electric vehicle on the road. Just like there's no single tool for every job, there's a whole family of electric motors, each designed for specific tasks and environments. Let's explore some of these motor varieties, each with its own unique strengths and applications. First up, we have the ever-reliable direct current DC motors. These motors are powered by, you guessed it, direct current, and they come in various forms. You'll find them in everything from toys and handheld devices to electric vehicles and robotics. Next, we have the workhorses of the motor world, alternating current AC motors. Remember Nikola Tesla? His innovations paved the way for these powerful and efficient motors, commonly found in industrial settings, powering pumps, compressors, and heavy machinery. Within the AC motor family, we have two main branches: induction motors and synchronous motors. Induction motors are known for their simplicity and robustness, while synchronous motors offer precise speed control, making them ideal for applications like robotics and automation. But wait, there's more. We also have specialized motors like stepper motors, which move in precise incremental steps, making them perfect for applications requiring accurate positioning, such as 3D printers and robotics. And let's not forget linear motors, which produce motion in a straight line, ideal for high-speed transportation systems like maglev trains. From the tiniest micromotors used in medical devices to the massive motors powering ships and locomotives, the world of electric motors is incredibly diverse. Each motor type plays a crucial role in our modern world, driving innovation and powering our lives in countless ways. Electric motors are the unsung heroes of modern engineering, silently and efficiently powering countless aspects of our lives. Let's shed light on their vital importance and discover how they shape our world. Imagine a world without motors. Our homes would be without appliances, factories would grind to a halt, and transportation systems would come to a standstill. Motors are the heart of modern infrastructure, keeping our world running smoothly. In industries ranging from manufacturing and construction to healthcare and transportation, motors play a critical role. They power assembly lines, operate robots, drive pumps, and keep our cities moving. Think about the everyday objects that rely on motors: refrigerators, washing machines, vacuum cleaners, computers, smartphones. The list goes on and on. Motors make our lives easier, more comfortable, and more connected. Beyond our homes, motors power the vehicles that transport us, the elevators that lift us, and the escalators that move us. They're essential for our mobility and connectivity. As we transition towards a more sustainable future, electric motors are playing an even more critical role. Electric vehicles powered by efficient electric motors are reducing our reliance on fossil fuels and paving the way for a cleaner, greener future. The importance of electric motors in modern engineering cannot be overstated. They are essential components of our infrastructure, enabling progress and innovation across countless industries. Now that we've explored the different types of motors and their importance, let's take a closer look at the key components that make these electromechanical marvels tick. At the heart of every motor lies the stator, the stationary part that houses the motor's magnetic field. The stator is typically made up of coils of wire wrapped around a laminated iron core. Next, we have the rotor, the rotating part of the motor that interacts with the stator's magnetic field. The rotor also consists of coils of wire, but these are mounted on a shaft that allows it to spin freely. Connecting the stator and rotor is the air gap, a small space that allows the rotor to spin freely without any physical contact with the stator. This gap is crucial for the motor's efficiency, as it minimizes friction and energy loss. To control the flow of electricity to the motor's coils, we use a device called a controller. Controllers can be simple on-off switches or sophisticated electronic devices that regulate speed, torque, and other parameters. In addition to these core components, motors often include bearings, which support the rotating shaft and reduce friction, cooling fans, which prevent overheating, and enclosures, which protect the internal components from dust, moisture, and other environmental factors. Innovations in motor technology continue to push the boundaries of efficiency, power density, and control. From new materials to advanced control algorithms, engineers are constantly striving to make motors even better. Understanding the basic components of motors gives us a deeper appreciation for the ingenuity and engineering that goes into these ubiquitous devices. Thanks for joining us on this journey through the fascinating world of electrical motors. From the basic principles of electromagnetism to the diverse types of motors powering our world, we've covered a lot of ground. We've seen how motors have revolutionized engineering, driving innovation across countless industries and becoming essential components of our everyday lives. As technology continues to evolve, we can expect even more exciting advancements in the world of motors. Stay tuned for more insights into the technologies that power our world.